Yeah, so Caleb's question was about muscle origins and insertions, and are we going super specific, or are we just going more general? And so I ask questions that are not super duper specific. I'm more interested in you understanding the function of a muscle. Okay, so for you to understand the function of a muscle, then you need to know number one, which joints it crosses. Okay, and then which aspect of the joint that it crosses over. Okay, like the examples I've given before, if a muscle crosses over the posterior side of the hip, then we know it's going to be hip extensor. If it crosses over the medial side of the hip, we know it's going to be hip adductor, right? So that's number one, importance. Okay, and then so by knowing that, you should know which bone it comes from, which bone it originates on, and which bone it inserts on. Right? But as far as the actual like specific name of the bony prominence, I don't ask a lot of questions related to that. Probably only the ones that I've really kind of focused on, like the pes anserine and a couple others like that. But beyond those, beyond the few that I've kind of made a big deal of in a couple of places, it's more just about which bone and where on that bone, as far as just kind of not the name, but the kind of the area of the bone that it originates from, and an area of the bone it goes to, and then which joint it crosses over and which aspect of the joint it crosses over.
Thank you.
Yeah, and you will need to visually identify muscles for the lecture too. Obviously, that's the big part of the lab. That's all that is in lab. But there will be figures on the exam where you see the muscle, you see a group of muscles, and you'll have to identify them. But it's typically more related to function, like an arrow could be pointing to a muscle, or a bunch of different muscles having a bunch of different ones, right? And it could be something like which letter is the muscle that is a hip adductor or something like that, right? So you have to be able to visually identify them and then kind of know its function from there. What else, guys?
I have a question. Are we supposed to know, like in the slides, the organic components and like the inorganic components?
Of bone, you're talking about?
I don't know, just on the slide, like in the first lecture, it talks about like the inorganic bones and the organic bones. It's like after the ossification process slide.
Yeah, the second one, that would be the bone development and homeostasis.
Yeah.
Yeah, you are. And so let's see, which slide is that? You said it's right after the, yeah, definitely. So the organic part is the collagen, right? The collagen in the cells, and then the inorganic part is the calcium phosphate salt. So that's what it is. Yeah.
Okay. And then on the exam, are we gonna have to say like what the ossification process is, or how are the questions going to look like for that?
Yeah, so knowing the steps involved in endochondral ossification, so that was definitely a good process one. Let me share my screen to show those slides here. Yeah, so this is a big process, right? That you'll need to know. Definitely want to know this process here, and kind of know all the steps there involved. Be able to kind of write it out in your own words with the right terminology. So yeah, you definitely need to know all the steps and the processes and what's going on there in endochondral ossification.
For the ossification process, for step 2, that the ossification cuts off the internal chondrocytes. Could you just explain step 2 really quickly?
Sure. Yeah, let me, can't see you guys anymore.
Like, is the dashed part why it hardens? Like the part underneath step 2?
Yeah, sorry, hold on one sec. I was just trying to figure out how I can see your faces again. All right, hold on. Okay, there we go. Okay, so the dash part, let me just, yeah, you guys can see my mouse there, right? Can you see my mouse when it moves? Yeah, okay, cool. So you're saying on the, on number, did you say number 2 there? Okay.
Sorry, yeah, my speaker cut out. Yeah, number 2.
Number 2, okay. Yeah, number 2, so the osteoblasts form the bone collar. So this is when pretty much those bone cells come in and they just create kind of like a shell around the bone. And so then that shell would be covering up the rest of the bone, which is still all cartilage on the inside. And by doing that, it cuts off all the nutrient supply to those cartilage cells on the inside, which causes those cells to die. So that's this part, the ossification cuts off internal chondrocytes from the blood. They die, leaving cavities surrounded by calcified cartilage. So it's pretty much just a bunch of little dead cartilage cells, and then that kind of causes them to harden and calcify a little bit. And so that's kind of that second step before. So then, then after that happens, then we can go in, and now the new blood vessels come in and bring in osteoblasts that can start replacing that calcified cartilage with bone tissue at that point. So that's kind of the number 2 is kind of the step to destroy the rest of the cartilage, so we can now start replacing it with bone.
Okay, thank you.
Yeah. What else?
I had another question. Could you explain the differences between the pennate and parallel muscle arrangements?
Yeah, for sure. So let me pull that slide up. Okay. All right, so here you can see the pennate ones. I think in a second when that updates. Oh, it paused. Oh, I paused. Hold on one sec. Screen sharing paused for some reason. I didn't think I paused it. Okay, try that again. Okay. You guys can't see that yet, huh? No. I don't know why it's taking so long. Give it a sec for it to come up. Well, I can do it without the pictures while that's trying to load. So pennate just pretty much means that there's this long kind of central tendon, and if it's unipennate, then we kind of have a tendon like this, and then all the muscle fibers are coming off in the same direction. Okay, so they're really just one angle of pull, and that's what pulls the muscle, right? If it's bipennate, then we have some coming this way, some coming this way. Okay. If it's multipennate, like the deltoid, then they're just coming off in many different directions, but still there's kind of the one tendon, but maybe multiple sets of that central tendon. Yeah, let me just try to stop sharing and see if that'll come back. Uh-oh. I think my Zoom might be crashing, you guys. Can you guys still hear me? Put your thumb up if you can still hear me. Okay. All right. Okay, good. I think that might be better. I don't know what's going on with my Zoom. Sorry about that. Let's try to share my screen one more time. Yeah. Something's up with that screen sharing. It's not working. Okay, but
you can have maybe one of us share our screen, and then you can probably work on that.
Yeah, that's an idea. Yeah, well, let me see. I can kind of just talk it out, and then if there's something that we get to that you definitely need to see an image of, then we can try that out. Okay, so that unipennate or bipennate or multipennate, it's really just that central tendon, muscle fibers coming off all in one direction, or bipennate 2 directions. Whereas parallel, they're pretty much just all straight down from one tendon. With the tendons here and tendons here, it's just muscle cells going straight down the middle of that. And so with the pennate arrangement, you definitely get a little bit more strength out of it. You get more force production. but not quite as much shortening. So you don't have the same range of motion that you would with the parallel. And with the parallel fibers or parallel fascicle arrangement, you get a lot of range of motion. Those are usually long muscles that can shorten a lot, but you don't get a lot of force production out of it. And because you just have one angle of pull and it's just going kind of real long, instead of having a bunch of different locations to be pulling on. So yeah, so that's kind of the main difference between those two. What else?
Could you go over the differences between osteoporosis and a stress fracture?
Sure, yeah. So the big difference is just local versus systemic in the bone. Okay, and so with a stress fracture, there's thinning of the bone, and with both of them, there's thinning of the bone matrix. So the bone itself just becomes less dense. Okay, so we have on the inside where that spongy bone is, with that trabeculae, those trabeculae, that kind of like web-like network of bone, that just becomes thinner. Okay, in osteoporosis, and the compact bone becomes thinner in osteoporosis, and it really will affect a whole bone, or at least a whole region of a bone when we're talking about osteoporosis. When we're talking about a stress fracture, it's usually just the point of most stress in a bone. Okay, so maybe that's the medial side of your tibia if you're a distance runner. Okay, and you've been just running so much, and there's just kind of one stress point that always tends to get the most impact every time you step down on your leg, right, on your foot. And that one point, which is kind of the weakest point, that's the part that needs to try to adapt the most because of the stress that's put on it. And so when it goes into the process of trying to adapt, some osteoclasts come in and start kind of thinning out the bone. And then there should be time for the osteoblasts to come in and lay down thicker, stronger bone in response to that to make it stronger for the next time. But a lot of times either the healing process just didn't give enough time, and so then then you hit it again hard with another workout or another stress, and then so that just causes more osteoclastic activity, but it's just in that one spot, right? And so eventually that happens over and over and over again. You just kind of have repeated osteoclastic activity, never with the chance for the osteoblast to fully lay down new bone. So then you're just thinning out that one little spot in the bone. And so both of them are thinning of bone and becoming less dense, but the stress fracture is very localized to one spot, whereas osteoporosis is the whole bone. What else?
Tendon sheaths are elongated bursa, right?
Yeah, they're pretty much just very similar to bursa, except they're kind of wrapped around a tendon. Obviously, instead of just like a sac, they're that same sac, but that sac would be kind of wrapped all the way around a tendon, and they're typically longer because they'll go around a whole section of tendon.
So could you get bursitis in a tendon sheath then?
It's not called bursitis at that point, but it's the same idea for sure. Yeah.
Do you have an easy way to remember varus and valgus?
Yeah, good question. Yeah, I don't have a good like acronym or anything like that. I mean, the way that I always remember it, just because I don't know, but it's probably just my athletic training background. I just always think of like an athlete or myself, like somebody getting hit from the outside of the knee and that medial side of the knee opening up. For some reason I always remember that's valgus. Valgus is a much more common one to happen, right? Because you typically have forces coming from the outside of your body versus the inside, versus the medial side, you know? So yeah, I don't have a good, yeah, I don't have anything good as far as like a mnemonic or anything like that.
No worries.
Yeah.
Thank you.
Did anybody else come up with something?
I think of valgus as in like Gus, and like Gus seems like a big guy, so I just like he would hit me from the outside. So like that's the way I think of it. I don't know.
That's awesome.
Mine's kind of similar. Valgus has the G, and so I think it goes like towards the gut. So like I associate the two G's.
Nice. Very cool. Thank you guys. That's awesome. Cool. What else?
I hate to make you stand up, but could you demonstrate internal, medial, and external hip rotation? For some reason, that just doesn't make sense to me. Like how
Yeah,
those
sure,
work.
sure. Yeah, no, you should make me stand up. It sounds good. And normally I'm always standing when I teach, except when I do these. So, okay, it's gonna be a little tricky. How would the best way be to do this? And you can see I always wear shorts when I teach on Zoom, which is fun. So I would never wear shorts normally, but so probably the easiest way to think about it, I guess, would be with your knee bent like this. And so this is my right leg, and it could be a little different because it's flipped. The mirroring on Zoom always throws me off a little bit, but this is my right leg here. And so if I did this, right, so that motion, okay, I'm gonna go back to normal. If I go this motion, that is external rotation of the hip right there. And what did you say the other two? Oh, you said the other term for that's lateral, right? Is that what you said? Lateral versus?
Yeah, so some of the muscles we need to know, it said like it helped in medial rotation, and I didn't really know what that was. And then I guess like the internal hip rotation. Like I just couldn't really visualize that.
Yeah, so we've got, so I typically don't use the medial lateral rotation terms. I typically just use external and internal rotation, but external rotation is the one that I just did. So your hip could go in like that. Okay, so it has nothing to do with what my tibia is doing. I could show you it like this as well, which would be like that, right? That would be like your foot going out. Okay, that's external rotation or lateral rotation. And then internal rotation or medial rotation is the opposite. So if my knee's up like this, it would be doing that. Okay, so it's when I go from here to there. And I could show you it with my foot here again. It's when your foot goes in like that. So you typically don't have much internal rotation or medial rotation range of motion. It just goes a little bit like that. So again, that's external or lateral. And this one is internal or medial.
Okay. And then kind of along with that, is that your hip that's moving or your knee or like both?
Good question. Yeah, your knee does have the ability to internally and externally rotate too, but that's a little.
All right. What else?
Can you go over the sternoclavicular joint?
Yeah. So the SC joint, or the sternoclavicular joint, is really just it's where the clavicle meets up with the sternum. So we're talking about it right here. Right? So your clavicle right down to where your sternum is in the middle. It's this joint right here. Okay. And it's considered part of your shoulder joint complex. Right. So with your shoulder joint, you have and one thing to think about with all the major joints that we talked about in that specific synovial joint section is how many bones are in each joint complex, and then how many bony articulations are in each joint complex. Okay, so with the shoulder, we've got the clavicle. We count the sternum actually as part of the shoulder joint complex. Okay, so the sternum, clavicle, scapula, and the humerus. Right, so it's got those 4 bones, and then the articulations. We got the SC joint, sternoclavicular joint, which does have a little meniscus in it. That's one unique feature of that one. It has a little fibrocartilage there. And then the AC joint, or the acromioclavicular joint, out here at the other end of your clavicle, where it meets your acromion and your scapula. And then obviously the glenohumeral joint, where the humerus meets with the scapula. So those are kind of the main things. Yeah, as far as those injuries go that we talked about in the shoulder, a shoulder separation is a sprain of the AC joint, or the acromioclavicular joint, whereas a shoulder dislocation is more a sprain of the glenohumeral joint, or dislocation of the glenohumeral joint where that humerus comes out of the socket. All right, what else?
I had a question about the knee. So for the purpose of this course, how many ligaments of the knee are there?
Yeah, well, the ones that you need to know are the medial and lateral, medial and lateral collateral ligaments, MCL and LCL, right? Then we have the 2 cruciate ligaments, the ACL and the PCL. And then we talked about the patellar ligaments, but that's really kind of more like a tendon, right? That's how the quads attach to the patella and then to the tibia. Those are really the four, yeah. So really just those four: the MCL, LCL, ACL, PCL are the four that you need to know in the knee for this class. Yeah.
On that note, when you say like ligament, can you just explain what that means one more time?
So ligament in general means a bone. It's connecting bone to bone, right? And the tendon in general is connecting muscle to bone, right? And so the one with the patellar ligament is it's this one right here on your knee, right? So between your patella and your tibia is right there, and when you contract your quads, you can feel that one tighten up, right? And so it is technically a ligament because it's connecting the patella to the tibia, so it's a bone-to-bone connection. But really, it's more like a tendon because it's really connecting the quads to the tibia, but it just goes through the patella first, and that's what kind of turns it into a ligament, is because it goes through that bone in the patella first. So it's kind of just a little bit of a crossover one there. It's functioning more like a tendon, but if we're going to be technical about it, then it would be considered a ligament. What else?
I have another question. For the synovial joints, are we going to be asked questions that are like show the pictures of like what joint is this, or is it going to be asking like what functions does this do, or like the multi-axis?
You're talking about the.
What are the questions going to look like with the synovial joints? Because there's like a lot of them.
Okay, are you thinking not synovial joints, but are you talking about the joint classifications and movements one, where we go through all the different types of joints, that one?
Yeah, like the pivot joint, the hinge.
Oh, yeah. So what you need to know there is you would need to know the examples of each type of joint that I have on the slides. And there's really only one or two that I have on each slide of the different types. And then you would definitely need to know the type of movement that's allowed, whether it's non-axial, uniaxial, biaxial or multi-axial. And so that's the main thing. Just know the examples that I give and the types of movements that are allowed there.
Do we need to know the planes that those movements are on?
I mean, it would be good to know for sure. But I don't, because I wrote those on the slides this year, I think, but it's not written on the slides without me writing on it. But yeah, it would be good to know. I mean, just especially when you compare that to each joint. So like knowing that the elbow joint is a hinge joint, right? And knowing that it allows for that uniaxial movement, and and you need to know that elbow flexion and extension is in the sagittal plane anyways. That's kind of what we know. But yeah, that's kind of more, I don't know if you necessarily, I don't know if I would ask any questions specifically on that, but it'd still be kind of good as far as your understanding of how the joint works. So for the ankle joint too, talk a little bit about that one, because that one kind of comes at the end of the notes. A lot of people tend to kind of get a little confused on those ligaments. So the ankle joints on the lateral side, which are mostly they're all coming from the fibula, right? They're all coming from that lateral malleolus. Those are the most commonly sprained most commonly sprained ligaments in the body. And then of those three that are there, the anterior tibiofibular ligament is the most commonly sprained one. That's the one that you get most of the time if you just kind of roll your ankle a little bit. And so just by knowing the name of those ligaments, you know the two bones that they attach to, right? The talofibular ligament, right, goes from the fibula to the talus, right? And then we got the calcaneofibular ligament, or the CF ligament, goes from the calcanea to the fibula. calcaneus to the fibula, and then the posterior talofibular ligament. That's obviously in the back and going from the fibula to the talus. So those are all the lateral ones. If you look on the medial side, coming off of the medial malleolus, then you've got the deltoid ligaments, and then you can just know those as the deltoid ligaments. There's multiple ligaments in there, but it kind of forms this like pyramid type complex of ligaments. So the way that we would stress the lateral ligaments would be with inversion, right? So when we, if this was my foot, if I would roll my ankle like the typical way we think about rolling our ankle when we step on the side of our foot, on the outside of our foot, and it rolls, that's how we would sprain those lateral ligaments. And then the other way, which isn't as common, if we stepped on the inside of our foot and it kind of rolled in, which is not as common, that's called eversion, right? And that's how we would sprain those medial ligaments or the deltoid ligaments. What else we got, guys?
Can you go over like bone growth and the blood calcium homeostasis?
Yeah. So let me pull that one up over here. Bone growth. Oh yeah, you're talking for blood calcium homeostasis. You're talking about the hormones.
Yes.
Yeah. Yeah. So we can talk about the growth part first. The growth part is there's two types of growth, right? We've got appositional growth, which is thickening of bone. Okay, and once your growth plates have closed, that's all. That's the only type of growth that can happen in those bones once the growth plate's closed. So we'll talk about this next semester when we talk about growth hormone. But there's two different disorders related to having too much growth hormone. One of them is called gigantism, which is when you get too much growth hormone before your growth plate's closed, then you get really tall, right? But then if you get too much growth hormone after your growth plates have closed, that's something called acromegaly, which just means you have really thick and hefty bones. And so you get big, thick facial features. Your bones are just much thicker, big kind of features of the forehead and in your facial bones. So that appositional growth would be what causes the acromegaly one. You don't have to know those terms for this semester, but that just is a nice application of it. And then the lengthening growth, which is the growth at your elongation growth at the epiphyseal plates. That is where we have that cartilage line on the end of our bones. And the bottom part of that cartilage line is those cartilage cells are dying and being replaced by bone. And so we're adding bone underneath that growth plate. And then the top of that growth plate, those cartilage cells are adding new cartilage cells. And so that cartilage is moving up as the bone is kind of chasing behind it, right? And so we're adding bone as we're going. And then eventually, after puberty, enough of the right mix of hormones interacts with that cartilage there and causes the cartilage to stop growing. So when the bone just keeps coming, it eventually just takes over all of the cartilage and just turns into all bone there. So that's the growth part. And then the hormonal control part, and I think that's what you're referring to on the blood calcium homeostasis, is there's two hormones involved. So parathyroid hormone, or PTH, and then there's calcitonin. Okay, and so parathyroid hormone is released when we don't have enough calcium in the blood. Okay, so if our blood calcium levels are low, then the parathyroid hormone is released from the parathyroid gland, and if we don't have enough calcium, then we need to pull calcium out of the bone. So we do that by stimulating osteoclasts. Right, the osteoclast job is to then go in and start breaking down bone, and when they do that, they release calcium into the bloodstream, and that raises our blood calcium levels back up. Okay, the other side of things there is if we have too much calcium in the blood, then that stimulates our thyroid gland to release calcitonin. There's another hormone, and that calcitonin stimulates the osteoblasts now with a B to lay down more bone. So they actually pull the calcium out of the blood, use that calcium to create some bony matrix, and that lays down more bones. And now we're storing that calcium there, and that lowers the blood calcium levels back down. That's about it. Does that answer your question?
Yeah, thank you.
You're welcome. What else?
What's the purpose of the soft callus in the fracture healing?
It's just kind of an early stage before we can lay down bone. It's just faster to get that tissue in there than it is to get the actual bony callus. And so it's just kind of stages. We start with the blood clot, which just happens because the bleeding occurs, right? And then it's the quickest next step is to convert that blood clot pretty much into more of like a cartilage type tissue, because it's faster to lay down cartilage, and so you get that soft callus there, and then from there obviously it's converted into bone, but even that is kind of more like a mostly spongy bone, and then from there the final remodeling of the bone, where we get the compact bone back and the spongy bone back, but then also that cavity again. So it's just kind of steps and stages, which is similar to the normal development of bone, where it starts as cartilage and then converts into spongy bone, and then can convert into compact bone. So it's just kind of part of the typical stages of development of bone. What else?
So I had a question about the joints. So on the study guide, it says there are 4 factors involved in creating joint stability. So do you mind going over the 4 factors and like an example for like the knee or like the hip?
Sure, for sure. Do you mind saying your name? I couldn't see your picture.
Oh, I'm Joy.
Joy. Okay, Joy. All right. So the 4 factors, and this would be right in, I can tell you which note packet this is in. This is in the synovial joints one.
Okay.
Before we got to the specific synovial joints, and it's slide 21. It says joint stability, and then it says contributing factors. And so the 4 factors are: number 1, the joint structure. So that's just the bones themselves and how well do they fit together, right? We talked about the hip having a very deep socket and a nice fitting ball that goes inside there, right? So that's the joint structure. Whereas with the shoulder, it's more like a not very. That's not even go maybe something like this, where we got a small socket and a big ball, right? It doesn't fit in there at all, so we don't get a lot of stability from the ball and socket joint or from the structure of the shoulder joint, but we do get a lot of stability from the structure of the hip joint.
Mm-hmm.
So that's the first one, structure. Second would be having to do with the muscles that help support the joint. And there's 2 types of support mechanisms that muscles can provide. The first one would be direct stabilizers. Okay, so those would be muscles that directly cross over the joint that we're talking about. Okay, so for the knee is the great example, where the quadricep muscles cross over the front part of the joint, hamstrings cross over the back part of the joint. When those contract, they cause the knee to flex or extend, but they also take the 2 bones and kind of squeeze them together too, right? If we're contracting those muscles, it's pulling those bones together, and that directly stabilizes the joints. Okay, so that's the direct muscular stabilizers. And then we have the indirect ones. And really the most prominent example, the one that I talk about, is the one looking at the hip muscles, in particular the gluteus medius muscle, which is a hip abductor, right? So gluteus medius is a hip abductor. It indirectly supports our knee, because if our hip is allowed to abduct as we're going down into that single leg squat, like I showed you, then our knee goes into valgus, right? And that when that knee goes into valgus, that puts us at a position that we're more likely to tear our ACL or our MCL. And so by that gluteus medius contracting as you're going down into that single leg squat, it holds your patella right over your toes, right? It keeps your knee in line with your foot, instead of letting your knee fall in. And that's important for stabilizing your knee. Okay, so that's the muscles part. So we've got joint structure and muscles, and then underneath muscles we have direct stabilizers and indirect stabilizers. And then third, we have ligaments, right? So which ligaments do we know of that cross over a joint and hold that joint together? And then within those ligaments, are they pretty strong ligaments? Or are they kind of weak ligaments, right? The examples there that we talked about, the hip has lots and lots of ligaments, and they're really strong. The strongest ligament in the body is that iliofemoral ligament, which is part of the hip. Okay, so very, very strong ligaments in the hip. The shoulder, on the other hand, has some ligaments, but they're pretty weak. They're pretty loose. They're designed to allow for the shoulder to have a lot of mobility instead of stability, right? To allow it to have a lot of range of motion, so we don't get a lot of help from the shoulder ligaments. Okay, and then lastly is the cartilage. The fourth factor is the cartilage. And really this is referring to, does the joint that we're talking about have a meniscus in it, or does it have some fibrocartilage in it? So the knee obviously has the medial and lateral meniscus. The hip has the what's called the acetabular labrum. Okay, it's a little cartilage rim around the hip. And then the shoulder also has a labrum called the glenoid labrum. And then lots of other joints have meniscus type structures in them, and they always help to deepen the socket a little bit and give you a little bit more stability. And so the medial and lateral meniscus in the knee help to deepen that socket quite a bit, so that's helpful. The shoulder does as well. That labrum in the shoulder increases contact area with the humeral head by 75%. So without that labrum, you have 75% less contact area between the two bones. And the hip also is helpful. The hip labrum is also helpful. So those are the four factors.
Okay, thank you.
Yep. What else?
You've said before, like when a muscle crosses a joint, that's something that we know. What does that do again?
So if a muscle crosses a joint, then we know that it moves that joint. Right?
Okay.
It has an action on that joint. So then the next question would just be, which aspect of that joint does it cross? Because then that'll tell us what movement it does to that joint. Okay. So if we think about, I'll just use my finger. I made my wrist as an example, since you can see that a little bit better. All the muscles that go over this part of my wrist, which would be the posterior surface, when I pull this way, my wrist has to do that, right? It's got to do that. So anything that crosses over right here has to be a wrist extensor, right? Because that's wrist extension, okay? Anything that crosses over down here, again, if I'm pulling this way, it's going to pull my hand down like that, right? So if it crosses over this side, it's got to be a wrist flexor, okay? So you can take, and same thing if we have muscles that cross over here on the lateral, or sorry, this is the medial side on my pinky side, and I'll put it like this so you can see it this way, it's got to pull down this way, right? If they cross over here, it's got to pull this way, right? So that's what I mean by knowing which aspect of the joint it crosses, because then you don't have to sit there and memorize, like, okay, these are all the flexors, these are all the extensors. Just think about where it goes, then you know what it does, right? You don't really have to memorize it anymore. You can just picture it on your body and picture if it pulls this way, then it's got to do that, right? And that's much better than trying to just memorize a bunch of words, right? And that's what I'm trying to get you to do, and by thinking about it that way.
Thank you.
Yeah. What else? Anything else, guys? We've got a few minutes left. If you got any more questions, if not, we can definitely sign off. All right. Well, sorry for the Zoom drama, but I'm glad we were able to figure it out in some way. But yeah, good to see you guys, and reach out if you have questions between now and the exam. I'm happy to help you out via email. Or I do have some office hours appointments still available tomorrow morning if you want to grab one of those. All right, guys. We'll see you soon.
Thank you.
Thank you.
Thank you.
Welcome.
Actually, I have a question about the lab quiz for tomorrow.
Sure. I'm just going to stop.